Hi, now I'm going to show you two kind of tricky things about naming hydrocarbons. So to understand that, I'd like you to look at this molecule and figure out why is it called 2-pentene. Now I know it's pent because there's 1, 2, 3, 4, 5 C's, okay, pent. I know it's ene because it has one double bond, and ene kind of runs with equals and the double bond looks like an equal sign. That's how I remember it, but you remember it however you want. Maybe it kind of looks like an E. Oh, no, that kind of looks like triple bond. So why is this called, what's the 2 though? Why is this called 2-pentene? All right. And the answer is because where is the double bond? It's off of the 1, 2, the second carbon. So that's one little extra rule, is that when you are doing alkenes or alkynes, when you say ene, it's an alkene, you are technically supposed to say where that double bond is, because it could be there, or it could be there, or it could be there. All right, so that brings us to another example. This is hexene because it has 1, 2, 3, 4, 5, 6 carbons, so hex. Ene because it has a double bond, making it an alkene. So this is hexene. Now, is this 4-hexene or 2-hexene? So you might be like, oh, Mrs. Hoover just taught me this. That's the 1, 2, 3, 4. Okay, the double bond is after the fourth carbon. But it's actually called 2-hexene. Can you guess why it's called 2-hexene, just to make your life harder? So it's actually, if you count from this side, 1, 2, it's off of the second carbon. So why did I count from that side? Well, the rule is technically you're supposed to count from the side that it's closest to. And that's just because, like, these molecules can flip around like 3D in space. So if I just flip this molecule around, it would go from being 4-hexene to 2-hexene. And I don't want something to have two names just because it flips around. So if I turn around backwards, I'm still Mrs. Hoover, right? I'm not going to have a different name just because I'm turned around backwards. So to prevent that from happening, to prevent things from having two different names just because they're flipped around, we made this rule where you count from the side that the double bond is closest to, or the triple bond. So we made this rule to prevent like having two different names just because you're flipped around. So the rule is you count from the side that's closest to. So if it's hard to tell, you just count. You go, okay, 1, 2, 3, 4. If I count from this side, it's 1, 2. Okay, it's closer to this side. I'm going to call this 2-hexene. So let's just do one more example together. So I'm like, okay, let me count the carbons first. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is oct. And then I'm not going to call it octane because I see a double bond, so I'm going to call it octene. All right, and then which carbon is it off of? Let me give it a number to show where the double bond is. And it's the carbon that it's after. So if I count from this side, it's off of the 1, 2, third carbon. If I were to count from this side, I'd be off the 1, 2, 3, 4, 5. Okay, that's not it. So it's after the third carbon. So the name of this alkene is 3-octene. Doesn't that make you feel so smart? That's why I like this. All right, and one more tricky rule, and this is getting kind of advanced, so I'm not going to test you too much on this, is branched hydrocarbons. I just want you to see them in case you see it in college. So I'm used to seeing like 4 carbons in a row. Now this thing right here, it has 4 carbons, but they're not like in one neat chain. So what this would be considered is this molecule with this little group coming off of it. So the way I could tell that this was branched, it was like one main chain with a branch coming off of it, is that I couldn't just sweep my finger across it in one clean sweep. I'd have to go like down and back. Okay, so this is a branched hydrocarbon. It has a branch coming off it. This is the branch right here. All right, so the rule for this is you just name the main parent chain, which is the longer. So if I were to count, okay, this way it's only 2 carbons. Okay, this way it's 3. All right, this is the parent chain. So let me erase my little doodles there. So I go, okay, this main longer chain is 3 carbons long. So that's 3 is prop. It's all single bonds, so ane, so it's propane. I don't need a number to say where the double or triple bond is because there isn't one. And then I'm going to name this little group. The little group is made from one carbon. I don't care about hydrogens. The word for one is meth, or the prefix for one is meth. And when it's just a little branch, I'm not going to name it like methane propane, just show it's just a little group coming off there. I'm going to give it an ill ending. So this is methyl propane. Don't you feel so smart? Let's look at this one. This looks branchy. But if I run my finger C, 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 that's not actually branched. I can run my finger along it in one clean sweep without having to like go down and come back up. It's just one clean zigzag sweep. It's actually just showing how these things are in real life, which is they're actually more zigzag than they are like straight. So the rule is you're going to find like the parent chain by finding the longest possible chain, and then everything else coming off that long main parent chain or the main backbone are branches. If the branch has one carbon, meth means one, so we're going to call it a methyl. If it has two carbons, eth means two, so we're going to call it an ethyl. We're not going to call it an ethane, it's just a little group, so we're going to call it an ethyl. And then if it has three carbons, prop means three, so it's propyl. So you're going to put the branches out in front and then write the name of the main parent chain. So let's just try two examples here. So this says draw a 2-ethyl 3-methyl pentane. If we were really in school, you'd get really good at this. But we're just going to kind of like sample it. I'll draw it for you. So I like to work backwards and say, okay, well, this is pentane. Like I like to go like right to the back where I get the parent chain. So I'm like, okay, 1, 2, 3, 4, 5. Okay, pentane. And then it says there is and it was pentane. So pent means 5, ane means all single bonds. There is a methyl group. Where is it though? Oh, it's off the third carbon. So 1, 2, 3. Okay, here's my third carbon. And a methyl group means 1C. Okay, so I put 1C off the third carbon. And then there's going to be an ethyl group. That means 2 C's off of the second carbon. So I could draw that. If I didn't have enough room, I could draw it up instead. A little messy, sorry. And that's it. I should go through and fill in with H's so that every C has 4 total bonds. So like right now, this C just has 1. So I'd give it 1, 2, 3 H's. And remember, I don't have to write the H's. I can just write lines. This C has 1, 2, 3. So I'll give it a 4th. This C has 1, 2, 3. So I'll give it a 4th. This C just has 2. So I'll give it 2 more. This C has 1, so I'll give it 3 more. So usually on the end, they need 3. This C just has the 1, so I'll give it 3 more. This C has these 2, so I'll give it 2 more, so it can get kind of messy and crowded. This C only has this 1, so I'll give it 3 more. And that is my final molecule. So we just drew a 2-ethyl 3-methyl pentane. Don't you feel smart? Let's try one more over here. So now they gave me the picture and I'm going to name it. So I'm like, all right, I see some branches. I can't quite I can't run my finger across this in one clean sweep because I'd have to like go like that and like kind of like double back over. So that definitely has branches. The longest chain, let's see, this is 3 in a row. This is 4 in a row. So the longest chain is the 4 in a row. So, okay, this is my parent chain then. And it has 1, 2, 3, 4. So that is bute. It's all single bonds. So ane, butane. And then I have 2 groups. I have this group and this group. It's not an ethyl. It's not 2 C's together. It's 1 C here. There's a little methyl group, and 1 C here. There's a little methyl group. So I actually have 2 methyl groups, and they're both coming off of the third carbon or the second carbon. Well, if second is smaller number, right? So I would count from this side, 1, 2. So they're both coming off the second carbon. So I'm going to say this is a 2, and there are 2 methyl groups. So it's a 2-dimethyl butane, meaning it's an alkane made of 4 C's with 2 groups that have 1 C, and they're off the second carbon. Right? So all this naming is just one big code to tell someone what something is. So that is a 2-dimethyl butane. Don't you feel smart? Hopefully you might see a question easier like this than like drawing the whole thing. Just says, given the formula, what is the name of the group in the box? So we just say, okay, well that group is made of 2 C's. 2 in organic chemistry is F. And then because it's a group, I'll just put ethyl, not like ethane. So that's an ethyl group. So just to summarize, we have kind of 2 little kind of trickier, more advanced rules for naming hydrocarbons. One is that this number out in front just tells you where the special thing is, like where the double bond is or where the little branched group is. And you have to remember that you're going to count from the side that that thing is closest to. So whatever gives it the smaller number. If I count from this side, this double bond's off the 4th carbon. If I count from this side, it's off the 2nd. So I'm going to go with the 2nd. So whatever uses the smaller number. And then the other rule is that if you cannot run your finger across the molecule in one clean sweep, then you've got a branch, and you're going to name the bigger part of it, the main part of it, the main chain, and then you're going to give special little group names to the little branches coming off of it.